This video is about how to calculate data of beam deflection. And if you'll recall, we did an experiment in class where we calculated or measured really the beam deflection um, based on a number of things. We used the moment of inertia of a beam, which we called IXX, or sometimes I think I call it I later, and it's related to the orientation of the beam because that affects the strength of that beam or plank. And then we did this stuff where students stood on this system and we calculated first the modulus of elasticity. It's in here somewhere. And then we used that information to calculate another student's weight. And so then we came to problem 16, which is here. And we've got this situation where, let's just read it. Complete the chart below by calculating the cross-sectional area, moment of inertia, and beam deflection given a load of 250 pounds of that guy right here, a modulus of elasticity of this enormous number, 1.51 million psi, pounds per square inch, and a span of 12 feet, or importantly 144 inches to keep our units in uh, good shape. Okay, so what we're asked to do is to complete this chart and then finally to use Google Sheets to create a beam deflection versus moment of inertia chart. Now, you can do that partially on the paper, but then and then take these data and just key them in one by one into Google Sheets. I'm going to show you an alternative way, which you may want to do, and let's have a look at that. So what I did here first was I just reproduced that table in Google Sheets. I called it beam deflection versus moment of inertia. Now I'm going to come over here and I'm going to delete some columns here so that I can show you that I've uploaded some images here to help us understand what's going on. And as you can see, the first row is beam. We call it A through F. And then the common name, 2 by 6, 2 by 8, 2 by 10. And then the actual dimensions here. And then in the handout, there was the actual orientation, a little picture. But I'm just going to use vertical to represent this area here, this orientation here, and horizontal for this one. And just so that I can keep things straight, I made the verticals blue so that I could just keep them separate. Okay, now we could go in here and we could use our calculators to calculate that here. I would think that there's a better way to do that, and there is. And this is one you should think about doing more and more. And I want to show you some things here. Let's see. Yeah, here it is. So when we look at things like area, which is just the product of the base times the height here, and remember the base times that we're not talking about moment of inertia yet, but the base times the height is just this part right here, right? The base changes, the definition of B changes when we flip it 90 degrees. So this is the algebraic expression for it. And as we'll see in a minute, many of you already know, depending on where you place the values of B and H, you can use this formula to calculate it for you, much easier. And moment of inertia we saw is equal to BH cubed over 12. And again, we got to be careful and keep our B's and H's correct. Are separate and identifiable, so B is the one that's horizontal. And so that equation in Google Sheets is right here. And then ultimately we get to the beam deflection, which is this equation here. And I haven't put in the formula here yet, but I will in a minute in this video, and we'll see that there's a good way to calculate that. And all these skills are incredibly important as you go on and do a lot of these calculations. They're time saving and you just need to know them. And this will be a review. I think we may have covered this at one point or another. Many of you already know it, so if you already know this, then maybe just sit back and watch and make sure I don't make a mistake. Otherwise, let's get started. So what I want to do here is when I calculate the cross-sectional area, I want to use that formula right here. I don't want to have to key it in many times over. So in order to do that, I need a separate cell, unless I get really fancy and extract it from here, which we're not going to get into, for the base and the height. And I've already done this before I did this video, and what I did is I put a separate place for the base and the height right under the orientation. So I just extracted the base and the height from this cell here, these cells here. And you can see that just 1.5 and 5.5. So I want to do that again. So I want to insert 2 rows underneath the vertical or horizontal orientation. Okay, so what I can do is click here, right click, let's see, insert above here, and I can do that again, above. And then I believe I'm going to keep referring back to this, which has all the answers, so to speak. Base B and height H. So let me do that. Actually, what I'm going to do is just go ahead, well, I'm just going to go ahead and copy that because there's no sense in me writing it. All I did was extract the base and the height from this cell here. And for example, C is vertical, so B is the narrow one, 1.5 there, and H is the, did I say B is the vertical? B is the horizontal on C. Or, yeah, that's the base, and then the vertical H is the bigger number, 7.25. So I'm just going to go ahead and save us some time by grabbing that. I'm going to hit a Control C here and go back to my other spreadsheet and Control V, and it'll just paste it in there. Now, what I can do here is I can use that equation that I was referring to earlier, which is right here. And I can calculate the area very easily for one cell, and then I can just pull the cell over, as you'll see, to calculate it for all of them. So here what I want to do is go equal, and then I can just click here. So that's B5, cell B5, column B, row 5, and then asterisk is multiplication, and then I click here, and that's B6, and it shows the value, and I hit enter, and I get that for the area, and it looks like that matches what I had before. Now here's the real benefit of doing that, is I can just grab this lower right portion here and pull it across, and I've got the area for each one. Okay, so that part is complete. I didn't have to use my calculator 6 times over. How about the moment of inertia? Well, the moment of inertia is a non-trivial equation, not that bad. BH3 h cubed over 12. You just kind of keep your B's and H's correct. So I can also just calculate that one very easily as well, because I have B and H here. So the equation I'm going to use is this one right here. So I want to use parentheses to make sure that I get the order of operations correct. And the caret means to raise to the 3rd power. So let's do that. Again, so I'm going to go into the cell that I want. I'm going to say equals, left parentheses. Now the base in this particular case is there, B5. asterisk times, and then H, which is 5.5, and then the caret, which is shift on the 6 button, raised to the third power. That's going to cube that. Right parentheses divided by just the slash and 12. So I get this value for the area. And I'm going to just cut down on the decimal points. We really don't need really more than 1. And now again I can pull these over and get all the areas. I'm sorry, the moment of inertia, because I have the B's and H in the same row. Now just for here, you saw that we have B5 times B6 cubed over 12. When I copy that over, what happens in this one is that it just shifts over as well. So now we've got C5 times C6 cubed over 12. So it's smart enough to know what I'm trying to do, and then it can go from there and make it easy on us. Now comes a slightly complicating factor. So for beam deflection, I can't quite get away with something as easy as that, because I have more than just B and H in there, and I have more than the moment of inertia. So I have B and H is not in there at all, actually. And we just have the moment of inertia, which is the I down here. But what about L, F, and E? Okay, so here's a very powerful thing you want to do. So I'm going to go to the completed one, and I'm going to grab this here. So what I did here is sort of below my table, I defined the force F, and then I put its value at 250s, and I put its pounds here. Then I said modulus of elasticity, and to get it to look nice, I had to right justify that. Otherwise, if the default, like left justify it, it looks like that, or center justify it looks like that. But if you right justify, you can get away with it looking like that. And I put in the given value and its units. And finally, the length. What these are constants that are not going to change as I put a value in here and then pull across. I don't want those to start to look at the cells to the immediate right like these populated. They were smart enough to go to columns B, C, D, E, and F, but I don't want that to happen. So here's how to make that happen. Not happen. So again, just to save us a little time, I'm going to go ahead and copy this little chunk down here, which are all the relevant quantities I'm given that don't change for any of these calculations here. And it's the force F, which is 250 pounds. Let's check that. Yeah, 250 pounds. The modulus of elasticity doesn't change. The force doesn't change. So these are constants. Now, but there is a way to handle those. So let me see if I can do that. So for here, I want to key in spreadsheet notation this formula. And here's how you do it. The key takeaway is that when you have something, a cell that you don't want to advance, as I pull these over like this, in other words, I want these values to stay the same for all of these. What you need to do is modify them a bit. So if I go to this formula here and come up here, you'll see that well, maybe it's just easier to go here. You'll see that it basically just cell addresses B5, B6, and those update to C5, C6 depending on how I extend the original cell. However, there's some notational changes you need to make here so that we get the right answer. A lot of email today. Okay, so let's come over here. Now for this one, again, we're doing the beam deflection here, which is FL cubed divided by 48 EI. So I'm going to say equal. Definitely need a parentheses to make sure I get everything in the numerator grouped together before I start putting in denominator. So here's the key thing. So force is at cell C11. And I want that to remain C11 as I pull this over to copy my results in here. So I only have to do it once. And what you have to do is you have to put a $sign before each of the cell elements. For example, this is $sign C $11, $sign C, $sign 11. So that's 250, and that's going to stay 250 as I extend this cell across here. Okay, times, also L is the same. This is actually 12 times 12 because I did some converted it to inches inside the cell here, and so I can just use this value, and this is element C 13. So I'm going to say let's see, $sign C, $sign 13 raised to the power 3, and I'm done with the numerator. So right parentheses slash for to get down to the denominator, and then left parentheses for the denominator. Okay, well 48 is just 48. Now times my modulus of elasticity, and again that's a constant for all of these values. So I'm going to do the same bit with the $signs. So $sign, what element is that? It's C12. $sign C, $sign 12, yeah, times, and now I don't have to worry about the $sign business because I want this expression to update as I drag it over here to pick out not 20.8 but 1.55, 47.63, blah blah blah, etc. over to here. So now I can just click in here to get that element, which is what, B8? Yeah, B8. And I think I can just close the parentheses for the denominator and hit enter, and I'm going to get a number here. Let me get rid of some of the, let's just go out to 3 decimal places. Let's see if it matches what I had before. Okay, it does. All right, now I can just pull these over and get these values, and let me check again to make sure that they match. That seems they do. Okay, so you saw how easy that was. I didn't have to calculate 6 different values each time. I created one for the first one over here, one formula. You can see it up there. Why don't I grab that formula to finish out my little cheat sheet there? So I'm going to grab that, come over here. Oops, wrong one. Control V, and then this one here. Whoops. Something like that. And so those are the formulas. And the $signs, again, do what I just described. Okay, wonderful. So that's how this can be made more efficient. Now the price I pay is I had to make a simple or another couple rows here to separate out the dimensions. I had to put a little sort of auxiliary table of constants so that I can access their values. But the bottom line is that these two uh, areas here, which I don't know, they're the ones I'm gonna graph. We're asked to graph beam deflection versus moment of inertia. Now, I'm no expert at Google Sheets. I've spent so much time with Excel, so I'm going to fumble possibly around this a lot, but I do want to show you a few things. So we're going to graph this down here. Okay? Now, I know there's experts out there who can graph directly from here, but I can't. Maybe somebody can tell me how to do that in class. But I'm going to copy all this stuff here. Remember, every single one of these is a formula. And if I paste it to a new location, it's going to start looking in different reference cells elsewhere, and I'm going to get completely different numbers. So what I want to do is grab this, right click, copy, and I want to come down here. I want to go here, right click, and I want to paste special. And I want to paste the values only. So now I want to make them just into numbers. So if I do that, I get that. However, let me keep the format. Oh, that wasn't very useful. Paste values only. Okay. I thought that was going to cut down on the number of decimal points. Okay. So you can see I've just copied this over here, but if you look here, as I click here, up in our formula bar, there's no formula. It's just the absolute number. Okay. Now, again, those who are experts here are going to say you can just graph directly from here. In my experience, it is useful to have things vertical in columns when you graph them. So, and also maybe this is an opportunity for you to learn about the transpose paste. So I'm going to right click, copy, come right here, right click, paste special, the transpose. What that does is it just, instead of being in rows, it's now in columns. Okay, now I can just usually grab this and get what I want, which is insert chart, but this doesn't seem to work very well. So if I come up here and I want a line chart basically, but you notice it's graphing both of these, and somebody who's an expert can tell me why that's the case, because if I just create a chart, let's see, I think I did it over here, trying to figure out what was going on. Let's see. Yeah, so I just put X and Y here as headers, and I put 1, 2, 3, 4, 5, and here these are just the square. So it's A1 times A2 times A2, A3 times A3. So I just squared it, and then I grabbed the whole thing and created a chart, and it worked fine. It put the X's here, column A, and the B's here. For some reason, and I'm sure I'll be embarrassed when I figure out why, I don't understand why, this doesn't work. So I want to tell you a method of getting around that. So you can still grab this. And I guess this is an early AI thing that's already available to us. But if you come down to the Explore area, it's going to say, well, what does this guy exactly want to do? So it's got a bunch of stuff here, and it doesn't really, oh yeah. So ask a question about shade. So right here I notice it says correlation of beam deflection and moment of inertia. So that's what I want. So if I click there, it's going to make the chart I want, which is sort of like this. Then I can click Insert Chart. So what it did there was it just said, well, what other ways can I graph this? This person isn't happy with the default, or else he wouldn't have gone to Explorer, I guess. And so along the horizontal axis, I've got beam deflection, and vertical axis, I've got moment of inertia. Let's make sure that's what we're asked to do. Deflection versus moment of inertia. It is. So it's going to look like this, and we can clean this up, and we should really. So like chart style for the title. Let's see. Okay, this could take a while, but you generally want to have large labels. Let's see. Well, font size. Let's make this like 24. Okay. Let's come up to these. Font size. Let's make this like 24. Big numbers are generally better. So where are we at? Font size. Label font size. Let's make that 24. We could make this one even more. Now for the chart title, I just want to edit the darn thing. Here it is. Correlation of beam deflection with moment of inertia, and it looks like we've got, let's see, look with, I'm just going to change this whole thing and call it beam deflection versus deflection versus moment of inertia. Okay, there it is. Okay, good. Well, let's make that a little, I mean, that's the title. Let's make it nice and big. Okay. Final thing we can do is maybe take a look at our these things. And blue's fine. I once fell in love with square ones, hollow square ones. So let's make those like that. I don't think we can make them hollow here. That was on Excel. So what you can see is, yeah, there it is. So I guess we could. Can we do format data? Can we data labels? That might be useful. Now here, what we might do is increase the maximum on the vertical axis. Maybe make the max something like I don't know, 125, just to keep the same. And then you can kind of see the its behavior. So for very small, oh, I got this wrong. Okay, so I have it reversed. Deflection versus moment of inertia. This is moment of inertia versus beam deflection. Okay. That may have explained a few things. So let's delete this chart. And I don't know if it has anything to do with, let's see, delete. I just want to move this over. Yeah. No, that's wrong. Wait. I want this one over here. There we go. So beam deflection versus moment of inertia. Okay, so I want to come here and I want to sort by moment of inertia in ascending order. So what I can do here is sort. Data does have a header row. By moment of inertia sort. Okay. Now I wonder if insert chart. Nope, still doesn't work. That's okay. So yeah, so I had that reversed. Moment of inertia is the independent variable and beam deflection is the dependent. No worries, I'm going to grab this, come down to explore, and correlation of moment of inertia versus there. Yeah, insert chart. So there we get what we want there. And again, I can go through all this and change it, but really it looks like this. And so this is sort of like a 1 over x type dependence. So moment of inertia here, beam deflection. I'm not going to go through and uh, do the correct modifications for readability, but the bottom line is that this kind of makes sense because if you plot this quantity, beam deflection, versus this quantity I, you're basically plotting 1 over x. So at very small values of moment of inertia, you get a lot of beam deflection. But as your moment of inertia gets large, you get less and less beam deflection. So you can increase your moment of inertia, if we go back to this equation, by how? By oriented in the vertical direction. Okay, so that's a way to get the graph that you want. So we had a little bit of roundabout there, plotting the wrong thing versus the wrong thing, but we caught it and flipped it. So there's a lot of in here about using spreadsheets, and you should really know all this stuff, and we're going to call it a day there. So again, it should look something like that. Thanks for watching.